Let's take a closer look at what we mean by signed and unsigned integers and where it matters. And this is a topic that can be very confusing. I've got a little project on the screen here. I'm going to build by clicking the build button here. And if we run it, we see what we see in the lecture slides. The first line is where we get the unexpected result. 32767 plus 1 equals minus 32768. Yet on the second line, we see a correct result, as we would expect it. If we look back at the code, the easiest way to do that probably is to step through it line by line. So if we click the debug button and say yes, we switch to what's called the debug context. Now pressing the F6 button on the keyboard lets me step through line by line. So there are our first three variable definitions, and we see a simple addition being performed and stored in Y. So the first statement we see on the screen is the following two lines. So size of short is 2. Well, that confirms it's 2 bytes. Now if it's 2 bytes, an unsigned will range from 0 to 65535, and a signed will be thought of as ranging from minus 32768 to plus 32767. And that's why we're seeing this overflow. 32767 is the maximum signed integer in a 16-bit word. So when we add 1 to it, it overflows. And that's what we see here. 32767 plus 1. We've gone off the edge of the cliff, as it were, come back around the other side, and we're down to the most negative number, minus 32768. Now, if this was used in a calculation, this could have catastrophic results. And in fact, it's one of the things you have to be very careful of, and it's always good to generate tests to test extreme values to make sure you don't have overflows and underflows. But I want to get to a different point, really. Let's look at the next line where we get the correct result. I'm not changing the sum. All I'm doing is doing what's called a typecast. I'm saying, well, unsigned short UY is the same as Y. But I'm putting this what's called typecast in here to stop the compiler moaning at me. Unsigned short. It's forcing it. You could think of it as converting, but actually it doesn't really convert anything at all. Look at the next line. Now, this differs from the first example because we've got a percentage U instead of a percentage D. So this placeholder is expecting an unsigned integer. So it's going to display it as if it was an unsigned integer. So actually, let's look at the memory and you'll see that UY and Y are the same data, just displayed differently. So step over that one. Look up here. Here we see what's called a watch window. We see A, B, Y, and UY. And the values are what we see on the screen. 32767, 1, and this value for Y, which was what we thought was incorrect, minus 32768, and UY, which is what we expect, 32768, positive. What I'm going to do now is change it to hexadecimal. Now, hexadecimal knows nothing about signs. It's just the bits in the data grouped into little groups of 4. So it's a 16-bit word. There should be 4 hex digits. 4 times 4 is 16. So each digit in hex represents 4 bits, as we covered in the previous lecture. So let's change the number format now. It doesn't want to do it. Hang on. That one there. Where are you? There you are. Click this one. Number format. I'm going to switch it to hex. Now, Y and UY, although they're different data types, in hex contain exactly the same value. In other words, the actual bits in RAM are identical. They're no different at all. All that's happening is we are considering one as an unsigned and another as a signed, and when we come to display it, we're treating them differently. And that's about it. Now, I remind you of the statement I made earlier. The exception to this is arithmetic. For adds and subtracts, no great harm is done. But if you, as you can imagine, when you start performing nonlinear operations, then results can be severely affected by having the wrong sign. So always check the range of your variables. Write in a way that gives you the correct result over the full range you're going to use. And when we talk about testing later, something called edge testing actually looks at that, looking at extremes and checking for overflows and underflows.